Okay, hi everybody. Here is the video for the first section of the last chapter of geometry class. So notice that the first section is 12.2, so we are skipping 12.1. So don't worry when we haven't had that. And you hear the bells, the wind chimes, and the cat in the background. Sorry about that. So in order to do this video, you will need your notes and a computer with the video, obviously. Please also have homework number 45, as well as your chapter 12 theorem sheet and your chapter 12 vocabulary sheet. So when I bring up theorems and vocabulary on the video, you should find them on your vocabulary sheet so you can find them again when you need them during a quiz or a test. Okay. So chapter 12 is about surface area and volume of solids. So those may be new terms for you, but don't worry, we will define them. So the surface area basically goes like this. If you were to take one of these solids, okay, this is a rectangular solid, a pyramid, a cylinder, a cone, blah, blah, and you were to try to cover it with paper, how much paper would you need? Okay, that's basically what surface area is. For volume, the basic idea is that if you were to try to fill any of these solids with liquid, say, for example, a solid that looks like the carton of a milk carton. Okay, how much milk would you need to fill that particular solid? Okay, and so we're making the leap from two-dimensional figures, which you draw on a flat piece of paper, which we've been doing pretty much all year, to three-dimensional solids. So these are solids that you can hold in your hand. Now, by solids, I mean three-dimensional. It doesn't necessarily mean that the insides are all solid. So like if you have a solid piece of chocolate, you expect it when you bite through it that there's going to be chocolate all the way through. And that's the way you think of what you think of as a solid piece of chocolate. And then if you have a hollow piece of chocolate, then when you bite through it, you can see that the figure, the rabbit or whatever it is open on the inside. There's space on the inside. So in geometry, the solids can be either way. It really doesn't matter. What makes them a solid is that they are three-dimensional. And notice that there are really two types of solids. Okay, one is called polyhedra, and these are made up of faces where the faces are rectangular or triangular, octagonal, whatever, pieces that fit together with no curves. So ones that are not polyhedra are things that have curves like cylinders, cones, and spheres. So we're going to be exploring the surface area and volume of prisms, pyramids, cylinders, cones. We're not going to be doing spheres. Okay, and pyramids we'll do a little bit, but not much. But prism, cylinder, and cones are going to be our main focus. Okay, so prisms have two bases. Okay, and here is a base, and here is a base. So if you stood a prism on its ends, okay, the bases are what would touch, the base is what would touch the table. And the two bases are parallel, and they are congruent. So on this prism, even though we can't see it, we know that this bottom base is a hexagon, just like this top base, and that it is parallel and congruent to this top base. Okay? So a prism is described by the shape of its base. So this prism would be called a hexagonal prism because each base has 6 sides. Okay, one, come on. Oh, shoot, it erased my whole thing. So here's my 6 sides. Each base has 6 sides. So prisms have 2 bases that are parallel, and they are congruent. This is a hexagonal prism. Has 6 sides. The faces on the sides are these guys. So here's 1, 2, 3, and we know in the back there's 3 more. And these are called lateral faces, or sometimes just faces for short. So they're faces and bases, basically. And the number of sides of the base determines the number of lateral faces. So for each side of this hexagon, there's going to be a corresponding lateral face. So there's 6 sides to the hexagon, 6 lateral faces. So the prism has 6 lateral faces because its bases are hexagons, which each have 6 sides. Okay, so that's your vocabulary. You can connect this with the vocabulary on your vocabulary sheet for chapter 12 and make sure you can find it. So here are different types of prisms. So, and again, they're based on the shape of the base. So here's the base of this prism is a triangle. So this is triangular prism. This is the base of this one is a square. So it's a square prism. This one is a pentagon. So it'll have 5 sides to the base and 5 lateral sides. Here's the hexagon again. Has 6 sides, 6 lateral faces. And this is an octagon. It has 8 sides, 8 lateral faces. And I have no idea how many faces this next one has because it doesn't look, I can't tell. Anyway, so you can have all different kinds of prisms. And remember, the bases, let's look at this triangular one. So the bases, this is a base, and then there's going to be a base on this back side. Why is this not a base? Okay, this is not a base, even though you could set it on the table, because it is not necessarily congruent and definitely not parallel to the side behind it. Okay, so those are not your bases. Your bases have to be congruent and parallel. Okay. So how do we find the surface area of a prism? And remember, surface area is if you were to cover all sides of the prism with a piece of paper, how much paper would you need? So the surface area of a prism is the sum. Is the sum of the areas of the 2 bases. Okay, that makes sense. You got to cover the bases of the prism and all of the lateral faces of a prism. So you have to cover all those faces and you have to cover the 2 bases. You don't want any left over and you're not going to overlap with the paper. And that's what the surface area is. Excuse me. So if you look at this little triangular prism here, in order to find its surface area, we would need to find the area of this base, the area of this base, and then we would need to find the areas of these 3 sides. So it's kind of hard to draw, but this one back here, this one back here, and then this one in the front, and we would need to add them all together. And that's the basic idea of surface area. Okay. So as always, there is a theorem that covers this and gives you 2 ways to calculate the surface area of a prism. And this is called a right prism just because these angles here, the angles between the lateral faces and the sides of the bases are right angles. So there are prisms that aren't that way, but we won't be working with those. So let's look at this first way. So the surface area is equal to 2 times the area of the base plus the perimeter, I'll shorten it, of the base, P-E-R-I-M, of the base, times the height. So on this little triangular prism, we're going to have 2 times the base area times, or plus, sorry, the perimeter of the base times the height. And that's going to give us the surface area. And that's the one we're going to concentrate on first. I'll talk about the second way of doing it later. But when you have a prism that whose bases have 3 or 4 sides, okay, this is the formula that you're going to use, because you can easily calculate this base area. For a square or a rectangle, it's base times height. For a triangle, it's 1/2 base times height. Okay, the key is being able to calculate this area. So let's give it a shot. Okay, so let's find the surface area of the triangular prism, and there's the answer, so hopefully we'll come up close to it. So first, we're going to identify what the bases are, so we make sure we're adding up the right thing. So identify your bases. Now remember, they have to be congruent and they have to be parallel. I'll use that shorthand. So pretty obviously, here's one base which is congruent and parallel to this other base. Okay, these other sides are not parallel to their other bases, okay? And they're definitely not congruent. So we know our bases are these 2 triangles. So we can easily find the area of the bases. Which is 1/2. Okay, the one edge, the base edge, oops, I'm just going to go straight for numbers. 1/2 times 5 times 8. Okay, 5 times 8 is 40. 1/2 of 40 is 20. And we're dealing with feet, so 20 feet squared. Okay, so third thing, find the height. And that's given to you as 12 feet. So remember, the height is, if you stood this thing up on one of its bases, how tall would it be? Okay, so this is your height right here, is 12 feet. Okay, so now we have to find the perimeter of the base. Because remember, what we're going for is, okay, 2 times the area of the base plus the perimeter times the height. So we know the area of the base, we know the height. Now we got to find this perimeter, and that's where it gets a little bit tricky, but you guys know how to do it. So in order to find the perimeter of the base, we need to add together these lengths. Remember, perimeters, we're building a fence around the base. Okay, so it's obviously a triangle, so we're going to have 1/2, oops, sorry, I got into my area there and I shouldn't have. Okay, so we need to find the length. We have the 5-foot length, we have the 8-foot length, we need the length of the hypotenuse. So we'll use good old Pythagoras, and we know that 5 squared plus 8 squared is equal to the hypotenuse squared, or c squared. We know that 25 plus 64 equals c squared, and that is an 89 equals c squared. And then we know we have to take the square root of both sides in order to get c. So c is equal to the square root of 89. You will want to use your calculator, and that length is 9.43. So now we can calculate the perimeter of the base, which is equal to 5 plus 8 plus 9.43. Okay, and that turns out to be 22.43. So that's our P. So now we can plug and play. So we have surface area is equal to 2 times the base, and we figured the base was 20. The area of the bases were 20, plus the perimeter, which we just calculated at 22.43, and times the height, which is 12. Okay, long story short, that ends up being 309. The way we calculate is 309.16. Okay, notice they got 309.21, and that's okay because that's just a difference in the way we rounded numbers. So there's the answer. So again, all we needed to find was the area of those bases and the height, as well as the perimeter, and then we're done. So take a few minutes if you need to, pause the video, and if you need to copy this, which would probably be a good idea because you will see problems like this in your near future. Okay, now we're going to do something a little bit different. We're going to use that second equation, and that second equation was S equals, surface area equals the apothem, remember the apothem from last chapter, times the perimeter plus the perimeter times the height. Okay, so how do we do that? Here's an example. So here we're looking for the surface area of a pentagonal prism. And remember, I said on the previous slide that if you had 3 or 4 sides on your base, so it was a triangle or a rectangle or a square, then you could use that first equation because it's easy to calculate the area of that. Okay, when you have something greater than that, you need to use the equation, or use the apothem, which we learned about during the last chapter. Okay, so what is the apothem? Remember, the apothem is a line going from the center point of the figure to the middle of one of the sides. So we make 2 handy-dandy triangles right there. And we're going to use that to find the surface area. So, step 1, find the perimeter and area of the base of the prism. So each base is a rectangular pentagon, so it has 5 sides. So we're going to multiply, remember that the perimeter, okay, is equal to the number of sides, 5, times the length of each side. Okay, and that's equal to 35.25. So here is the length of each side, and you're multiplying it by 5 sides, you get 35.25. Now, here we have, so we've taken this little triangle and we've moved it down here, and we're given that each of these sides of the triangle is 6 feet, and we're given that this whole side is 7.05 feet, and you need to cut it in half to figure out what, for instance, this length is. So we know that that length there is 3.525, and we use good old Pythagoras. So I'll do the initial setup is a squared plus 6 squared is going to equal, wrong. A squared plus 3.525 squared is going to equal to 6 squared. Okay, so what they did here was they did the math for you, And it turns out that the apothem is equal to 4.86. So now we're going to use the formula for the surface area that uses the apothem. And that was just, I wrote up here, surface area is the apothem times the perimeter plus the perimeter times the height. And here's the apothem. Here's the perimeter, which we calculated up here. Okay, then there's the perimeter again. And then the height was given as 9. So we do all that math and we simplify, okay, and this is our answer. So the surface area of the right pentagonal prism is about 488.57 square feet. Okay, so it's just a little bit more tricky because you haven't used the apothem a whole lot yet. But just remember that when you have 5 or more sides on the base of a prism, you're going to have to use this apothem equation. If it's only a triangular or a rectangular prism, you go yay, and you don't have to calculate the apothem. Okay, so one more thing to learn in this section is the surface area of a right cylinder. So cylinder is like a Coke can. Okay, Coke. And Coke can. Okay. And the way they describe this is pretty neat. So if you look over here, here is your whole Coke can. So imagine that you took a pair of tin snips or scissors and you cut the can apart so that you could flatten out the cylinder part, okay? And then here are your top parts, right? Here's the top of the can and the bottom of the can. The tab top or opening would be on that one, okay? So what this is showing you is that to calculate the surface area, you're basically just calculating the area of this rectangle, which is the sides of the can, okay? And you're adding the area of the base, or adding the area of the top and the bottom of the can, which are circles, okay? So you know how to find the areas of a rectangle, okay, and you know how to find the areas of a circle, okay? So it made something looking really curved, okay, and how am I going to figure that out, to breaking it apart and seeing that it's just a matter of calculating the area for a rectangle and 2 circles. So, surface area of a right cylinder. So the surface area of a right cylinder is equal to 2 times the base, makes sense, plus the circumference of the base. So this this line that wrapped around the top or the bottom of the can has got to be the circumference of the circle. Okay, so it's the circumference of the circle, and again, here's our height. So all of these equations use the height. And then if you work all that out, you realize that this is just 2 pi r squared plus 2 pi rh, where r is the radius of the top or the bottom circle, and h is the height. So it turns out that's actually pretty easy. So let's try one. Okay, so you're wrapping up a stack of 20 compact discs. How old is this? Using a shrink wrap. Each disc is cylindrical with a height of 1.2 millimeters, tiny little things, and a radius of 60 millimeters. Okay, so you've got a radius of 60 millimeters, and each teeny little CD is 1.2 millimeters. Okay, so what is the minimum amount of shrink wrap? Because you remember, you don't want any overlap, you don't want to have any left over, needed to cover the stack of 20 discs. So we have 20 discs here. And you see how I'm annotating the picture? And if you get a problem like this that has a picture, the best thing to do is annotate it based on how they describe it, and that will help you access those numbers easily. So the 20 discs are stacked. So the height of the stack is going to be 20 times 1.2 is equal to 24 millimeters. Okay, so this is the whole height of the stack is equal to 24 millimeters. Okay, so all we got to do is plug and play. So the surface area is equal to 2 pi r squared, okay, plus 2 pi rh, 2 pi times 60 squared. Remember, our radius is 60, plus 2 pi times r, which is 60, and h, which is 24. We throw that into our calculator, and you will need at least 31,667 square millimeters, or about 317 square centimeters of shrink wrap to cover that stack of CDs, again with no overlap and no extra. Okay, so we've just measured the surface area of those CDs. Okay, again, if you need to pause the video and take more notes on this, please go ahead and do that. Okay, last problem. Okay, find the surface area of this box. Now, back in my grandmother's day, this would have been known as a hat box, where people stored their fancy hats. Okay, you don't see them very much anymore. Certainly not, and they could get really big. But, so anyway, we have this box that's basically a cylinder. Okay, and we know the radius is 8 inches and the height is also 8 inches. So in this case, we're going to use our formula for the area of a cylinder, which we know is 2 pi r squared plus 2 pi rh. And this is really just plug and play, which you guys are good at by now. So 2 pi, our radius is 8 squared, plus 2 pi, our radius is 8. Okay, our height is also 8. Oh, looky here. So we have 2 pi times 64 plus 2 pi times 64. Okay, and if you plug that into your calculator, you come up with 256 pi. And it's fine to leave the answer like that. If you want to calculate it out, you use pi equal 3.14, and we come out with 803.84 inches squared. Okay, so that's how much paper it would take to cover the entire area of this box. Okay, that's it. So good luck with the homework. If you have any questions, please ask. And I'll get the next video going as soon as I can.